Now we're going to see a topic called as deadlock. So just by seeing the picture, we can just see that there's a traffic jam being happened over here, and where the vehicles are not being able to move from one side to another. So there is no progress at all. So this is what actually the deadlock. So in operating system, how that particular deadlock occurs, what do you mean by that? We're going to just see that. So in operating system, deadlock is nothing but it's a fundamental concept in the operating system in which the set of processes gets permanently blocked because each process has been waiting for a resource which is held by another process in the same set. So this is what called as deadlock. So another way of saying, we can just say waiting for something for infinite time in which there is no progress for waiting processes. So progress will not be there. It will be idle. It will be stopped over there. So that is what called as deadlock. So you can just see an example over here. So there is a small area to cross. The vehicles, two vehicle can't cross. Two vehicle can't cross at a time. Only one vehicle can cross. So when both the vehicles tries to cross over there, so during that time the deadlock occurs. So this is what called as deadlock we say. This, in this picture, you can represent the deadlock using the resource allocation graph. So this is what resource allocation graph in which the process is actually is being given in circle and the resources are being represented in square, and then the request, if a process is having or it is a resource being already assigned in sense, the arrow is from the resource to the process. And if a process is being waiting or if it requests another resource, it is towards, that is from the process to the resource, the arrow is being marked. So here we can just see there are two processes and two resources. Process 1 already, resource 1 has been assigned to process 1, and similarly the resource 2 has already been assigned to process 2. But process 1 couldn't complete its work as it requires resource 2 also to complete its work, which the process 2 is having. And similarly, the process 2 couldn't complete its work as it needs a resource 1, but that resource 1 has been already with the process 1. So this this cycle is what called as deadlock. So here the progress is not being seen. Both the processes have been waiting for the process for the resources where the other process is having. So this is what called as deadlock. So here we can just see there are four main conditions. We call it as Kaufman's condition. And if those conditions it holds simultaneously only during that time, deadlock occurs. The very first one is mutual exclusion, and that is mutual exclusion is nothing but when a resource is being held up by one process at a time. So one process alone, a resource can be allocated to only one process. So such a thing is what called as mutual exclusion. And then hold and wait. So hold and wait is nothing but the process. What it does is unless it completes the work, it holds the resources, whatever resource it has, it holds the resources and it waits for the other resources to receive. So that is what happens over here. You can just see here process 1. In process 1, R1 has been already holded or it has already been assigned to process 1. but it requires R2, so it's waiting for R2. So this is called as hold and wait. So here in the real time example, we can just see there are two persons. So the man, he already has mobile, and he wants laptop and a car. So he requests for the laptop and the car, but the car is been already it has been assigned to another lady. So the deadlock occurs because the car has been already assigned and it has been waiting for by the other person. So here deadlock occurs. This is what called as hold and wait. And next, no preemption. So here resources forcefully it will not be taken away from the process. So whichever resource is having, it should not be forcefully taken. So in such a situation, in case forcefully is being taken, no deadlock will be seen. So it cannot be forcefully taken. So during that time only deadlock occurs. And circular wait. So circular wait, you can just see there that a set of processes. Okay, like over here we have four processes. So in that process, the P1 it's already holds one resource and it waits for the other resource which where another process been holding. So here P1 already R1 has been assigned and it's waiting for R2, but that R2 has been assigned to already it has been assigned to P2, but this P2 what requires or requests R3, which is already been assigned to P3. And this P3, what already it requests for R4, but that R4 has been assigned to this P4. Then P4 it needs R1. Okay, it needs R1, but that has been assigned to P1. So it is in a circular manner it has been seen. So this is called a circular wait. So when these four condition occurs, like what mutual exclusion, no preemption, hold and wait, circular wait. So when all these four conditions are true, during that time only deadlock occurs. In case if any one of the condition is false, deadlock will not occur. So these four conditions should be true. So in case if such a condition, if a deadlock has occurred, so these deadlocks can be handled by four different methodologies. So there are four methods. So one is deadlock prevention, and then deadlock avoidance, deadlock detection and recovery, and ignoring deadlock. So we can try to avoid the deadlock or we can prevent the deadlock. But in case if a deadlock occurs, okay, if a deadlock occurs, the deadlock has to be detected and it has to be recovered. So these methods we'll see in the next class or next video.